Hi everyone, I'm Talor and today I'm happy to introduce EnIGMA, our system for discovering security vulnerabilities using LM agents. This work was done in collaboration between Tel Aviv University, Princeton, and the NYU. Language model agents have shown promise in solving complex tasks, especially in domains like software engineering. But can we build LM agents that effectively work in the cybersecurity domain? That's the motivation behind EnIGMA. To test this, we focus on Capture the Flag or CDF challenges, a standard way to benchmark cybersecurity skills. What is a CDF challenge? Let's look at an example of a challenge taken from Hack the Box platform called Rookie Mistake. In this cryptography challenge, we are given a short description and two files, a Python script, genpy, and a text file, output.txt. On the left, we can see the genpy file, which is the script that encrypts the two parts of the flag. On the right, we can see the output.txt file, which contains the output produced by the script. We can observe that the first part of the flag is encrypted with the RSA ecosystem, and the second part of it is the private key of the Diffie-Hellman key exchange protocol. To find the vulnerabilities and find the flag, we first look at the first part, and find out that the RSA encryption was done with the prime modulus, which helps us recover easily the decryption key and decrypt the first part of the flag. The second part requires to solve the discrete log problem with a twist. We will skip that part. Finally, after we write a script, we can decrypt the flag and submit it. So solving CDFs isn't just about writing code, it's about exploration. It's about running programs, connecting to servers, debugging binaries, and exploiting real vulnerabilities. So how can we get language model agents to actually do all that? We identified two main challenges in current agent systems applied on the cybersecurity domain. The first is that many essential cybersecurity tools like GDB for debugging or Netcat for connecting to servers are interactive. They require ongoing interactions rather than single commands. In current agent systems, such commands will be blocked, as in the example here, or simply fail because no input can be given by the agent. To address this, we introduce interactive agent tools or IATs. These are agent-accessible command-line interfaces with the same read, eval, print loop as humans rely on. Here is an example of this loop taken from a debugger session using GDB. The user sets a breakpoint at main, the debugger evaluated it and printed out the resulting output, then a new iteration of this loop starts all over again. We also designed these tools to be non-blocking, so the agent can manage multiple tools at once, mimicking how real security analysts work across terminals. This is made possible by our custom agent computer interfaces for debugging and for server connection. The second challenge is output. These tools often return large logs or even binary data, which LMs aren't good at processing directly. To fix that, we introduce an LM summarizer. It receives the tool output and condenses it into concise natural language, tailored for the main LM agent. With these components, EnIGMA sets a new state-of-the-art on 3 out of 4 CDF benchmarks, containing 390 challenges. But we also had to make sure models weren't cheating, for example, memorizing flags. We define a case of solution leakage as when a flag is retrieved without appearing in any tool's output, indicating potential contamination. We observed that only Claude Sonnet suffers from this type of solution leakage, while other models that we tested don't. Finally, we discovered an unusual behavior we call soliloquy, where a model hallucinates a plausible challenge solution trajectory using the interfaces of EnIGMA but without running any action on the environment. To conclude, EnIGMA shows that interactive tools and output summarization are key to unlocking LM agents in the cybersecurity domain. If you are interested, you are welcome to visit us in the poster session or read the full paper. Thanks for listening.